Alright, hey everybody, this is Tim, back again with another video. Been a while to upload anything, but I figured this would be a interesting tutorial. So it's kind of similar to something I've done before, but I recently saw a post on the Houdini Facebook of someone asking, like, how do you do like inflating and exploding bubbles? So like bubbles that you can, like blowing bubbles and then they explode. So I did something like that like 2 years ago or something. I made somewhat of a setup. I never did a full tutorial for that, and I decided to sort of revisit that and do an actual proper full tutorial for that, and also introduce some other things that weren't in that setup, and do like make it at least look not terrible, because the render I did for it was absolutely terrible. It's this. So this was the old thing. Yeah, so it was the old thing. I'm not sure why I went with this sort of ugly metal look thing with whatever. Anyway, this is the old one. Never did a full tutorial for that, only a short tutorial-ish thing. We didn't build it from scratch. And I figured I wanted to do revisit that, doing a full tutorial with some interesting new things. For example, I recently discovered how you can also remove stuff from a vellum simulation, because I kind of always assumed that wasn't possible, because if you remove geometry from a vellum simulation, stuff will completely break and start acting weird. But it's actually possible. The trick is to remove the constraint and the geometry at exactly the same time. And if you do that, so within the same subframe, and if you do that, then it all works. So we're gonna do that. So yeah, we're gonna make this this bubble popping effect. So the new one. Whoa, yeah. Let me grab it again from here. Let me turn on my video. So yeah, we're gonna make this thing. There's some couple of so it's not just emitting some bubbles, but there's more to it than just, because if you just did that, it would be pretty easy. But what actually happens as well is they have an impact point, like a random impact point, and they actually sort of shatter from that point, like a real bubble would do. So there's actually some more interesting stuff going on there. And again, I reworked this setup a little bit to make it a little bit more on the interesting side. This is what we're gonna make. Yeah, so I guess let's just dive into that. And also just a sort of teaser of some other stuff that I'm gonna be doing soon. Is I've been working on quite a big thing at that thing. That's why I haven't uploaded anything in a while. But I'm working on a sort of 35-ish second short animation, which is getting close to done now. But like I started that back in March with the idea I wanted to just do a quick, fun sort of video, and that got off kind of like client work got in the way, and it was like way like and I kind of underestimated how much work it would be as well, because I was just like I wanted to like I kept reworking parts, but that's starting to get pretty cool. I'm pretty excited how that's turning out, and once that is out, so it's just first initially with that I'm just gonna release this short film on the YouTube channel. And after that, I'm going to do a whole range of tutorials around that. So full course on how everything is made, some recordings like this, or streams on just talking you through the project, things I learned, etc, etc. So that's going to make for a whole lot of content. So that will hopefully make up for the lack of content for the past couple of weeks. So that is coming at some point. But anyway, before all of that, let's actually do a tutorial on how to inflate some bubbles. So yeah, let's just dive into Houdini and yeah, make some inflating, exploding bubbles. All right, so we're here inside an empty Houdini scene, and yeah, let's just have a look also at the final effect that we kind of want to build. Ooh, like that. Oh, by the way, let's first set our project as well. I'm not gonna do the project setup that I normally do, so just do just type it out. We're gonna just do the renders all in one folder. It's nothing too complicated. So let's just set a project here. We have an empty thing, and we need a couple of tubes. So these little tubes. So I guess let's make a tube. By the way, if you want the files to this thing, they're available for Patreon supporters on patreon.com/TimVanDelsdingen, or you can get them on Gumroad if you just want the file, don't want to be a Patreon supporter. That's fine as well. No matter what, you're helping out the channel, so thanks a bunch. But yeah, let's make a geometry node, and let's call it simulation. All right, here we go. And yeah, let's make a tube. So let's make a tube. And by the way, for some basic stuff, I assume you know the basics of Houdini whenever you're watching these tutorials. If you don't, you can check out Houdini 101 on my playlist. That's a beginner tutorial, 20 hours of Houdini introductory stuff. So if you're completely new, check that out. But anyway, let's right click on our height and paste relative references in the center and divide it by 2. So that way, no matter how high we make our tube, it will stick to the ground. Let's make it a polygon. Let's give it maybe a couple more columns. And let's do like 0.5 radius or something. A little bit more in height. So I guess something like that. And let's do poly extrude. So let's just extrude it out. And let's enable output back. So we also have a little backside. Right. Maybe we can also just bevel it already. Group. And let's make a group node. We go to edges and do include edges. And disable include by edges and enable include by edges and do minimum edge length and disable the base group. This way we can sort of say a minimum angle. So now to group the things with a minimum angle of, well, this. So this will be the very, well, angular edges. Then we do poly bevel and we select our group that we made. We could give it a name, but for this it doesn't really matter that much, but we just want to bevel it just a little bit and just give it 2 divisions. All right, beautiful. So yeah, now we have to copy them sort of to a position, and I'm actually gonna not do a regular copy. I'm gonna copy it to a line because we're gonna use the line later as well. So normally you would do copy and transform maybe, and then you would say, all right, we're gonna do it like this. But I'm actually gonna copy them to a line because I'm also gonna be using the line to emit later these bubbles. So let's make a line, and let's make it in the Z position. So Z direction. Let's make it like 10 or something. Let's do 5 points. So the points will determine how many there will be. So let's do target points, that one, and copy the line. All right, beautiful. So then we have our thingy. If you want to center it, you could also do that. You could copy parameter, and then you could. Which origin do we need? We could do origin, paste relative references divided. Oh no, we should do this negative, I guess. Oh, what am I doing? I'm messing up here. Negative, divided by 2. All right. So if you were to do that, then it would sort of stick in the center. You don't have to do that, but you can do it, and then it's all nice and center. Gotta have some coffee. All right. So now we have these things. And we can just, I guess, call them out. So null out tubes. Easy does it. And then we want to, later we're going to emit some stuff, but let's first already sort of explain, we're going to make a bubble, right? So let's now, before we sort of do more here, let's make a sphere. And let's make it a polygon sphere. Just give it a couple, like up the frequency a little bit. And if you type if you do tab and then type vellum configure balloon, just drops down 2 nodes that are configured to make it a balloon. And we're gonna just try this out to sort of inflate a thing first before we do anything other with it. So this we're gonna make the simulation in a DOP network. So we're not gonna use the SOP vellum tools, which are, by the way, just prepackaged DOP networks. But we're gonna make our own little thing. But let's first just drop down some nulls. Geo, and the second input is the constraints. So this one holds the geometry, which is all the geometry attributes here. You can see in the constraints are these things, which are the constraint attributes. We're going to talk a little bit more about these later. But first, before we do that, let's do a vellum solver just to test this out. So drop it down, put the geometry in the first input, constraint in the second input. Let's revert. Right, so if we now press play, it's going to fall down. Nothing too interesting. It's because we have some gravity. We could turn it off and it would just do nothing. We want to inflate it. So if we go into pressure here, we can increase the rest length scale. So this thing has a rest length. If you check on the constraints here and then go to primitives, you can see rest length. So that's the sort of the length, like how long are these constraints that are in here. And if you make those longer, like let's say I make them 5 and press play, it's gonna increase them by 5 times. So you can see immediately it inflates. So you can see that works. So we can use these constraints in our DOP network. So let's talk a little bit about these constraints here, because that's that's also something that that's kind of important. So if you just drop down a delete here, and let's just go and check some of our, you can see in the down, you can see bend and stretch. So how it works in Vellum is actually every constraint is, it's like, it might look like one object here, but it's actually multiple different groups which have their own constraints. So if I do delete non-select on bend, so these are the bend constraint. So these are the bending of the thing constraint, sort of. These have their own attributes here. And like if I do the stretch, so this keeps the stretchiness constraint, and all of that is configured, of course, on the nodes here. So there's the stiffness for stretchiness. Here, these stiffness. Where's the bend? Here's bend. So these are the bend constraints. So yeah, those are all sort of their own primitives. However, we also need a pressure constraint, because what we're gonna do here, stretch. This is gonna do the inflation, and we kind of want to sort of have this be their own group, because it's not in here yet. So if we just select this in an output group and just call this pressure, for example, you could call it whatever you want. You could also call it cheese. It would work the same, but like pressure probably makes more sense in this scenario because we're dealing with pressure. But I mean, if you're feeling funky, you could call it cheese. All right, so now there's pressure. And you can see this is, these are, well, again, different primitives. So these deal with the, with the pressure of the thing. Don't ask why they look so weird. I'm not sure why they're shaped like this, to be honest, but these do these things. And you can see they have the rest length here and the rest length origin, or rest length orig. So again, like if you inflate these, it will inflate. And this is the original rest length, which you can then use to compare, sort of like if we want to inflate it, and we can say like if the like rest length is bigger than 5 times the original rest length, for example, stop inflating, something like that. If you watch my bubble inflation tutorial, like the other one with the, if you watch this one, I'm also talking a little bit about, by the way, on my website, you can find like a lot of tutorials and stuff, and courses, and of course, can have a lot of big courses, also free courses. Yay, go. And like Patreons can have things there. Super nice. Anyway, so yeah, you're also dealing with that, but I figured I'd go a little bit more in detail sort of on some of these things, because I've gotten some questions also about stuff like this, and I figured I'd explain some things here in a little bit more detail. Right, so now we know that this stuff works. We're gonna make this. We can just delete these, or you can keep it if you want. But let's just delete it. We're gonna make our own little sort of DOP network. But what we're gonna do is we're actually gonna instead of just throwing this into DOP network, well, let's just first, by the way, maybe just make one DOP network. All right, go in there. By the way, if you don't know, like I have my view split. If you go to the thing here, you can do split top bottom, or alt with the bracket thing here, and you can link them together. So let's say if I link these to one, like this will always be linked to one, and you can link your viewport to either one or the other. So if you didn't know that, then now you do know that. So I always work with this sort of split view, because it's just easy to sort of drag to, you don't have to constantly jump in and out of things. You can, of course, if you have a second monitor, you can also link it to, like, for example, 3, and then have that. All right, let's do vellum solver in here. and then do object. All right. And let's remove the initial geometry here. So that's what would, like if you put it on SOP level, it will always just grab the stuff from the initial input. So that's why that is there. Let's do a vellum source. Oh, not a volume source, vellum source. No, source, vellum source. All right, there we go. Whip. And let's put geometry in there. Geometry. Whip. And let's check it out. Whip. Right. And that's working. And if we were to do the rest line scale to 5, then technically reset. Then technically that should, oh, I should put the constraints actually in the constraint path, right? Right, you can see that also works. So then we already recreated what we had before. But instead of just loading it like this, if you want multiple things, you can actually instance stuff inside of vellum. So you have these instance on point stuff. So we have this line here, and conveniently, those are points, right? That's what I mentioned before. Those have a couple of points, and those are conveniently in the center of our tube. So we can use that to sort of start inflating, some of our stuff. Maybe I should make my video feed a little bit smaller so you can see a little bit more. Right. So here we have that thing, and we want to instance on that stuff. So let's just try it. Let's just call this, pick a null instance point. All right. And drag that into the, so if you put this to, now it's set to only once, let's say instance on points, then we get an instance points thing. We can drag that in there. Boop. And this will do it every frame. So let's not do that. And let's in activation first just type $f equals 1. So now it will only do it on the first frame. So you can see on the second frame it will go to 0. But if we now go and check this thing here and just press play, you can see, whoa, yay, we got some inflating balls. Super nice. Big inflating balls. Should make them blue. And we got big blue inflating balls. Oh, why are you not doing it? Why are you not? I guess it's not the most important thing ever, but oh wait, I put it on the tubes. Wait, oh, I want my yay! Now we got blue inflating balls. Super cool. All right, let's remove the color. Enough of the levity. All right. So anyway, you can instance stuff inside the thing. So that's how it works, but it will do it every frame. So we later will need to write a little expression in here to like only do it like every couple of frames. Of course, we don't want to do it on all of the points at once. So what we want to do is like link again to our second view. And let's have a look. And let's first do is an add. Let's put an add SOP here and delete geometry key points. So we only have the points. Boop. Now let's do a blast. I want to blast something away. So I want to blast away the 0th point. Boop. And delete non-selected. You see now we only have 1 point, but are pointless because it's always in the same spot. So that wouldn't really do much for us. What we can do is we can sort and then point sort to random. So you can see this will randomly sort of select one. So if you put like, let's say $f in here, it will do a random one every frame, but you can see it's sort of not completely random. So maybe we want to make it a little bit more random. So let's do it times at time or something, or just do right. So that's a little bit more random. Again, you could do this however you want, but now it will just randomly blast away a frame. So we want to instance on that, but of course it's still, this is going, like if we were to go in here and let's check, it would, if we just were to set this to 1 now, so it would keep doing it. It would do it every, yeah, right. You can see this is gonna, It's cool, but it's they're like they're spawning inside of each other, and it does give sort of a cool sort of, I guess. But it's just really slow, but it kind of looks pretty cool actually. I guess actually you could sort of, if you were to make sure that they wouldn't spawn inside of each other, this could actually make for something pretty cool, if I'm honest. Like look at it. All right. Anyway, we don't want that. We want to do it every couple frames. So that's where like a modulo comes in. So let's turn off our simulation icon thing here. That's it's behind me. That's this thing. Right. Let me just move my face there. Right. So let's turn that off. And type $F. And let's say if I type modulo 15 or something, and if I just go and press this thing and see what happens, step through it, you can see it will repeat itself after 15 frames. So that's all cute, but it's obviously not what we want. We want just because the activation is either 0 or 1, right? It's a Boolean operation, 0 or 1. So what we can do is if $F modulo 15 equals 1, then it's going to evaluate to 1. So if we now step through it, see every 15 frames, it goes to 1 and then it goes back. So if we were to now play this, and let's reset our sim here. Right, so that's already a little bit better. Of course, they're still gonna not be in the correct spots, but yeah, that's kind of what we want. Let's, by the way, do the rest length again to 1, so that they don't necessarily inflate. So that's kind of what we want. So we also want them to sort of flow upwards. Let's do a pop force. Let's plug it into the particle forces. Let's do like 2, so they will move upwards. Now you can see they will spawn and then move upwards. They probably they should move. Let's, by the way, do our frequency a little bit lower, so it's just a little bit faster to work with now. And we could probably do the force a little bit more. But yeah, that works. Right, so let's introduce our collision. So our troops here. Let's do static object. Let's call it collision tubes, something like that. Let's merging collision tubes there, and do it like that. Bam, bam. All right, there we go. So let's drag it in SOP path, and let's also just drag it in object path, even though it doesn't make sense. Let's just do it, YOLO. Right. So we have that thing. And we need to say that they should be, there. By the way, we should make the spheres probably like a lot smaller. Let's do 0.1. Right, that's 0.3. So that's sort of inside the thing, right? And we probably want to move our points up a little bit here. So because now they're sort of there. Let's sort of move them with W on the keyboard. By the way, you can do the wireframe mode. Right, let's move them that they're sort of start in the center here, right? So we want to set these collision tubes to surface collisions because vellum uses surface collisions. But default is volume collisions because most stuff in Houdini uses volume-based collisions. How that works is that you have if you have a volume, so an SDF, signed distance field, VDB, then everything has like a real inside or outside. So let's say if I have this thing, I make a VDB, then surface here would be 0, then inside here would be positive, or the other way around. Oh, I always get it the wrong side, and then I would like increase outwards here. So there would be a real inside and outside. That's really useful if you're doing like flip or pyro, because there's actually inside and outside to objects. That's how collisions there work. With vellum, it uses just regular surface collisions, which just checks for intersection. So it's going to check for intersection between a primitive or point So that's what you want to do here. So yeah, all right. Now when you did that, it's not gonna do much, but now it's at least they're over there. So we have some stuff emitting. So we're getting somewhere. Pretty cool. All right. So now let's do the inflation stuff. We're gonna want to do the inflation stuff actually inside of DOPS here. All right. So let's do a vellum constraint property. And so that will allow us to sort of override certain properties on our object. And by the way, let's also just set our project to 30 frames per second instead of 24. You can keep it at 24 as well. Let's do 30, because it makes more sense, I guess. If you're gonna do one of these things, probably gonna be for web purposes. Unless you want to make a movie or something, you're gonna do 24. Anyway, doesn't matter. So we have these constraint properties, and we can use it to override these properties that we also had over here. But if we just tried it out, like if I were to put the wrestling scale here to 5, and if I'm gonna disable this, if I'm gonna press play now, it's gonna completely crap out on me. So let's watch what happens. All right. So that's not what we want. So remember what I told you with these different constraint here. We only want to do it on this pressure constraint, right? Because that is the one that's gonna need to inflate. The rest is used to sort of keep this thing like sort of shape matched and do all of these things. So do stiffness, do whatever. We only want to do it on the pressure. So let's do type pressure. And if we then, let's do, right. So then it will work. We can also, let's disable that. So now you can see this does work. We're not going to do it with this constraint property here. We're going to do it actually in a wrangle. We're going to do it ourselves. So do a geo wrangle. And in the geo wrangle, it's kind of like a wrangle on level here. You could also do it in a VOP, but the thing, we're just going to do very basic stuff. So like, don't worry, we're going to do very simple wrangles. If you're confused about VEX stuff, if you just keep doing this sort of simple stuff in VEX, eventually it'll start making more and more sense. Like most of the time I only use like very simple VEX. I'm not a particularly great coder or something myself. But for simple stuff like this, it's just a lot easier than doing it in VOPs. You could do this in VOPs, but we're going to do it with a GeoWrangle, and then you're going to learn some VEX. So let me just take a sip of my coffee again. All right. So we're going to use this to inflate some stuff. So first, let's say pressure group. And another thing that we need to change here, because else it's not going to work. Because if we say, for example, if we were to say f at res length times equals like 1.2, so it would do it every frame and set the primitives, this won't work. So if I'm going to press play now, you see nothing happens. So why is that? Well, the reason being is that there's actually here, if we select our vellum solver, by the way, if you're confused with like the flow of data inside of DOPS, which is pretty confusing. So how it kind of works, we have this vellum object here, and this contains sort of our data. So this sphere will be inside of this thing. This has like all of our, all of our geometry. This thing solves it. So this sources it, this processes it, and then this contains. And then it gets put inside of this thing. And then here's some forces that like get fed into the solver, into the processing thing. So it kind of goes like this. So, and if we had gravity here as well, for example, it would go like, and then this would process it. So it's kind of like everything goes in. So it's not a linear sort of top-down structure like it is with like it is with regular SOPs. It just kind of all just feeds back into each other. So anyway, if you select this thing, and if you can go into this vellum object, again, that's the thing that contains data, and just check it. So you see there's multiple things here. So we have the geometry, so also the patch, that's vellum specific thing, collision geometry, constraint geometry, patch geometry. So geometry is just this thing here. So the actual geometry, and the constraint geometry is the constraint. This is the stuff we had over here. So we want to run this on the constraints, right? So we want to type here the name that we have over here. So this, because this thing you can see has all of the rest length origin, and the geometry doesn't have any of that. It has some point stuff, but no other things. Right. So type the name there, constraint geometry. I think you could probably even rename the thing if you want, like bindings. I could probably, I'm not sure if this is going to work. Let's say if I name constraint geometry cheese instead. Okay, I guess that doesn't work. Does that work? Okay, it does use it by default. Thought maybe I could rename it. Right, just gonna keep it at constraint geometry, but sometimes you can also just sometimes you can just do custom names for your collision, for your data types. But I guess the solver does expect it to be called like that. Anyway, constraint geometry, and then on the GeoWrangle here, also constraint geometry. So now it will run on the constraint geometry. Let's call this thing inflate. And if we play now, you can see, oh, they're getting so big. Oh. Right, so obviously we need a way to sort of tell it to not keep completely inflating. But yeah, that's where we can use this rest length origin, right? We have here, where is it? Rest length origin, original, or rest length orig. So we could, in that case, we could say that, all right, let's do an if statement. If rest length below rest length orig, and then times, let's say like times 10, and then we're gonna do something. So only if it's below the original rest length multiplied by a certain value, so only if it's like the original rank by times 10, then it's gonna do this thing. So we're gonna play now. Where's our geometry? All right. Could probably increase this a little bit, and maybe decrease the how fast it's gonna inflate. Okay, maybe it should inflate reasonably fast, right? And you can see now it will inflate and then it will stop inflating. Right, beautiful. Let's enable the collision tubes. And let's push play. Okay, we probably want them to not be as big, and maybe inflate a little bit less fast. We want them to sort of just briefly stick their head and then keep moving. So as you can see, there's not enough force to sort of keep pushing them out, and then other stuff will spawn in the bottom, which is going to be problematic. So probably want to do another GeoWrangle. And just actually, so the force will sort of push on it, and then if there's friction, like if there's a lot of friction, it will push on it, but it won't be enough to sort of push it through. We can also just override some of the positions. So let's keep this on points and on actual geometry. And let's say p.y plus equals, let's say 0.01. So it's gonna, no matter what, gonna add 0.01 to the position every step. So that way it will just, no matter what, just push it up a little bit. If you wanted to be a little bit more specific, because we only kind of need this as long as they're sort of inside this thing. So you could do an if statement here that if p.y is below, let's say how long is our line, or how high is our tube, more precisely. So let's do, oh no, we don't want to do that. All right, let's just type it, 1.9. So the length of here of our tube is to 1.9. Maybe just let's do 2, and then we're gonna do open and close. So just a very simple if statement. So we're gonna only do that as long as the height is below 2. So after that, they will not be pushed up by this thing anymore, only by the forces. Let's call it push up or something. Let's introduce a little bit of noise in our force here. So they also get blown around a little bit more. Maybe can actually do that a little bit more extreme. Don't feel like it's doing much. Let's really increase this. All right, so okay, there's stuff that isn't going exactly as planned. All right, let's do it a little bit more like this. Maybe we want to increase the amplitude by the height. Let's just try that. So so this is, if we hover over it, amp times equals p dot y, maybe something like that. So the higher they get, the more they get influenced by the amplitude. Right. Let's do the base amplitude a bit lower because we do want them to, okay, we don't want them to sort of start sticking to each other like they are there, right? All right, so something like this, really pretty good. So that's sort of the base thing here, just with just basic bubbles. But now we have to deal with the other thing. Just grab the video again. So yeah, we have the base effect. Then now we want to sort of start initiating a blast at a random time, and then we want to sort of grow a attribute around it. And once the attribute completely engulfs the bubble, then we want to remove it from the simulation. So I did it in my original from 2 years ago. I actually didn't remove them from the simulation. I moved them like out of the way, which of course isn't like as fast. Now we're going to actually remove them from the simulation. So that's kind of cool. And of course, there's some interesting stuff just involved in just randomly selecting some points and stuff like that. I didn't have that in my original either. There they were sort of just hitting stuff that was flying in the environment. All right, so let's start doing that. All right, so kind of what we want to do is make a SOP solver, and SOP solver will allow you to use SOP nodes inside of DOPS. So let's dive in here. And what kind of want to do is do a for each. So what a for each will do is we'll loop over all the geometry and do stuff for each of the things. And we want to do that. The problem here, if we do this by connectivity, this will create a connectivity attribute. So if I just go and look at this thing, if I do connectivity, so it will make a class attribute if something is connected. But the thing is, we are spawning more stuff in. So the connectivity would change every frame. So we don't necessarily like that, because if we do color, just double check, maybe it's actually fine, but let's do random from attribute, and that's the class. So here it does actually seem to not necessarily cause issues, because it is adding them one after a time. But maybe if we want to be sure that nothing strange will happen, because this might actually be fine. But let's actually add an attribute that we know for certain will sort of always be original. So if we go on our instance points here, let's add an attribute on there. So an attribute wrangle. And let's say, let's create a sort of an ID attribute. So I add my ID equals, and let's type some stuff here. So let's say, all right, we want to do, it's going to be at frame times at time. Do we want to do something else? We just want to be sure that it's sort of random, somewhat random. Let's do again times frame. Right. So if we go and look at this, this should be, we should probably say rint, because it's expecting an integer. So it will round to integer. It's still complaining, but whatever. Right, so let's have a look. So you can see every frame there's going to be a new MyID, which will be unique for the most part. Unless you emit a lot, then you might need to do a little bit more advanced vex here to create a random thing. Call it MyID. If you go into the dot network here again, on the vellum source here, we can actually extract instance attributes from the points. So if I type MyID here, we now press play. Go to right. So let's go through it. And if I check this thing, there should be on the points here. So it should be MyID. And the MyID will be whatever we put here. So you can use that to extract attributes from your instance. And you can use a lot of interesting kind of things. You can use to, for example, extract p scales, extract whatever, all kinds of information, and you can use that again in your SOP solver. So it's quite a useful thing. So if we run on this thing, let's put it to points and let's put it to MyID. You can see now it will run on all the points instead of geometry. That's fine because we want just the points. So that is actually that is completely fine. Let's do blast. Let's blast the 0th point and non-selected. So that will blast the 0th point for every single one of them. Let's do not single pass. You might ask why we're doing it. Well, we're gonna transfer an attribute from that thing. We're gonna do this from a random point, so we wanna sort of do another sort, similar to what we did before. We wanna sort of sort randomly the point that we're gonna blast. So let's say $F. So it's gonna randomly do it. All right. And I'm just gonna sometimes glancing over to the right here because I have my original file here just to make sure that I do it roughly what I did before. Right. So kind of what we want to do is want to sort of at a random frame, we want to start sort of doing this and then start sort of transferring from that point. So let's do a wrangle here. And let's maybe not do the blast here. Let's do the wrangle. And let me just check what I did there. All right, so let's do a random float R, and let's say random at the point number. So create a random between 0 and 1 for every point. And let's fit that. So let's say float max equals fit 0, 1 R3 9. So it's going to fit the 0 to 1 between 3 and 9. Then we can use that in an if statement. So if the p.y position is below, is above the max, then we're going to do a thing here. And then say if point number does not equal 0, remove point 0 pt num. So this is kind of like we did with the blast. So if the point number is not equal to 0, it will remove the point. So it will kind of it will only keep the 0th point, and it will do this if the y position is above 3 units or it's above the max. And again, we randomized the maximum to be between 3 and 9. So at a certain height, at a random height, it will blast a thing and then just keep it. For some reason, it's not working. Let's do. Why? All right. What we also want to do is also if y is below max, then we just want to remove all points. Right. So now there should be only some points left above a certain threshold. Below max, remove point. If it's above, then only keep 0 point. All right, that seems to work. I'm not sure how I feel about the constantly jittering around of these points. Let's just remove the seed for now. We can change that later maybe. So that's going to be something like that. All right. All right, so we have that thing. And then we also want to set an attribute for this. So let's do grow equals 1. So we're going to initiate a grow attribute. And we want to transfer an attribute from here, the original thing, to this thing. And we're going to be grow attribute. All right. We're going to be grow attribute. And let's just have a look. Oh, let's do color. Let's check the wrapped color. And let's do grow. And let's do on here. Let's do. Let's check if there's actually already a point here. We need to have a frame where there's actually a point. All right, there's a point there. Color. And let's increase. Let's do it maybe just like something like this. All right. That seems to be quite okay. So yeah, we kind of want to keep the. All right. So if we're just gonna press play on this, this is not gonna work yet, but we can check what it's gonna do. So it's gonna get to a point, and you can see it does add the color, but it's not it's not growing across the thing yet. Maybe we'll do attribute blur this a little bit, and blur the grow by just a little bit. And still doesn't do much. So what we kind of want to do is want to keep, because now we're constantly transferring from and to, kind of want to do an attribute VOP. And we want to grab the original geometry here, do the second input. I want to add the original stuff. By the way, we should probably do this already run. I want to add the original color to the new color. So like that. And let's go in here and let's do a point cloud open. So point cloud is kind of like attribute transfer. It just looks around a certain point and it's gonna, so it's gonna look around every point. Then it finds points and you can extract stuff from these points. So I'm gonna look around position of every point. File, second input. Max radius, max points. Let's just leave it at default. Let's do PC filter. Plug that in. Let's do grow attribute. And let's do bind. Type grow. So we're gonna add something to our original grow. So this is gonna grab the grow attribute and it's gonna add the grow attribute from the previous frame. And then we're gonna output it again to grow. Like that. All right. So, and let's do the blur after that, and then the color. Right. Let's see what this does. Right. So now you can see it will, because it keeps the stuff from the previous frame as well. So it kind of sort of grows and blurs around the sphere. So it does the transfer. It sort of blurs it and it adds the one from the sort of previous position. And again, so the previous position will of course like already have something there. So that's why it doesn't stick in place. Also, it's just gonna do that thing every frame. So now we have this thing. So growing around our little bubbles. So we're getting somewhere. So the main thing here that's inside this thing that's left to do is actually removing them from the simulation once they are fully engulfed in their grow attribute. So this is their grow attribute. So here they should still be there. And then boop, once this happens, they should be removed. So yeah, let's dive into how that is done. Or before we do that, by the way, maybe a couple of things that we want to do here. We have a for each loop. For each loop, are single threaded. If you want to multi-thread them, I'm not like if you only have a couple of bubbles like this, probably won't make a big of difference. But you can multi-thread them if you do a compile block. And so compile block here, and then a compile block over there. And this doesn't support every node in between here, by the way, but these should be supported. Now you can turn on multi-thread when compiled, and now this will multi-thread. So it will just run every iteration on a one thread on your computer. So technically this should be a little bit faster. Again, probably you won't notice this. Like, it was already pretty fast, so it's like I can try to see if there's actually a big difference. We can try maybe do a performance monitor. Let's do performance monitor, record, and press play. Let's just do like 90 frames or something. Actually, it was a lot faster with the compile block. Now I'm looking at it like this. All right. Right, 91 frames. Where's the for each? Vellum solver. One solver. Is this with the compile block or without? Oh, this is with the compile block. All right. For compile block. For each. All right. Solve solver took 991. All right, let's try turning off the compile block. Would be funny if in this case the compile block actually makes it slower, but would be just a thing. Anyway, then at least still you know about compiling, and it doesn't matter. All right, let's just disable it like that. All right, let's do another performance monitor. Record. All right. All right, funny thing. Actually, it does seem like without the compile block, it was faster in this case. I don't know why. Maybe because we only have so few iterations. So let's, I guess, for now, just remove the compile block. But if you have a lot of iterations, compile block can really make a difference. So let's just stop this thing. All right, so that was interesting to see. Can we remove this again? Right. Alrighty then. All right, so what were we up to again? Oh yeah, let's do another thing here. Let's do wrangle. And let's say if at grow is above 0.1, let's say that at grow equals 1. Because we don't necessarily want a fade. We want it to sort of be hard because we're going to use this to blast away points. So this is one thing that we still want to do. Right, so now it's more of a hard fade. All right, so in this thing then, again, kind of what we want to do is we're going to do another for each. And we can just keep the connectivity for this thing. Doesn't necessarily matter. Let's do an attribute promote. Want to promote the grow attribute. Grow, where are you? Did we put it on? It's a point attribute. Should be there. Oh, grow. Let's put it to detail. Let's grab the average and not delete the original. Let's call it new grow. So you want to check for the average of the grow attribute. And again, once the entire thing is engulfed, the average will be 1 because there will all be 1. Oh, we should probably say that in here, if grow is above 1, grow equals 1. Because if it's gonna keep adding the previous frame, then it's gonna add on top. So we want to max it out at 1, because as you can see here, there were a couple that were above 1, but now we are limiting that. So anyway, now, all right, so point to detail. So detail will just average it out, and then it will put them on here. So now you can see, probably if we didn't do this, right, then, all right, so in this case, let's just first put it back. All right, let's promote it back again, from detail to point, new grow, delete the original. So now we should have a, oh, let's do new grow. Now we should have a new grow on here on the points. Let's have a look. All right. All right, so you can see some are 1. So probably now if we didn't have this thing, then I think some averages might be above 1. No, they're not. All right. Anyway, it doesn't hurt to keep this in here. So anyway, if they are 1, we could probably say that, all right, we want to initialize an attribute to remove them. We don't want to remove them already. All right, let me just show you what will happen if I just remove them here. And that's a problem what I always ran into before. If I would try to remove stuff from a vellum simulation. So let's say that new grow equals 1. We want to delete them. So you can see that one is deleted. So let me just play through this with this delete in here, and then you're gonna see what's gonna happen. All right, stuff completely breaks. So that's because the problem here is that we deleted the geometry. So this is the geometry, but there's still constraint geometry there, which is there, but there's nothing is connected to it, and then vellum doesn't understand what's going on. That's the problem that we have here. All right. So now the trick is going to be that we're going to need to delete these two at the same time. So we don't want to delete it here because we kind of want sort of in a step before here, we kind of want to delete the constraints before we do this other thing. And well, of course, like we cannot, like if we delete them here, then there's like it cannot, like then it would delete them on the other time step. So what we're going to do instead is sort of write out an attribute on this thing. So if new grow equals 1, then mark equals 1, or at, let's say just delete equals 1. Well, let's just initialize the delete attribute. So now it won't delete them, but it will initialize sort of a delete attribute. So if we go in here, so you can see now some will be marked as deleted, but they're not deleted yet. So let's call this mark delete. Maybe give it a color or something. So now they are marked for deletion. And then we can do some other stuff. So let's do an output node here. So it's going to be the output. So now we need a second SOP solver. So it's geo solver. So another SOP solver, and let's do it before this one. SOP solver, right? Let's call it constraint solver. And let's dive in there. Before we do that, let's again type this on constraint geometry because we want to run it on constraint geometry. So dive in there. So here we have our constraints, but these of course won't have this attribute because again these are separate things because they're completely separate objects inside of this thing. Like geometry, constraint geometry, they don't have the same data. What we can do is if we copy this dot geometry here, here it says the input, like what data does it need to load. So you can see this set to constraint geometry. That's linked up to whatever set there, which is correct for this thing. But we also want regular geometry. So let's just, instead of this stamp thing, let's just make it regular geometry in here. So we have regular geometry in this thing. And then we want to do attribute transfer. I'm going to transfer the attributes from our regular geometry. And we want to do the, what do we call it again? We're going to call it delete, right? Yeah, right. So you can see now, so we transferred them from the regular geometry to the constraint geometry. And in here, we can do a delete again, delete expression. And we can say delete equals 1. Right. So now you can see it will delete this constraint here. So then we're not ready yet because we, let's do output here. And we now kind of also, now when this is deleted, before we again loop into this thing, kind of want to delete the geometry as well. So we could, I guess, do this before on here. We could do a check, or we could just do a wrangle in between, geo wrangle. Or maybe let's just do it in the top here. Let's do null. Right. Let's do delete. Delete by expression. Add delete equals 1. Oh. Right. So let's delete it. Right. Let's play through it. I think this should work. Last time I did it with a thing in between there, but I think this should also work. All right, and you can see, deleted, and deleted, and so you can see here, it's there for 1 frame, and then it gets deleted. You could, of course, bake a threshold into there, like, because maybe you don't want it to exist for 1 frame over here. So you could, I guess, stops over here also say that if new row is like above like 0.8 or something, then it would be marked for deletion. So in that case, it would probably be deleted a little bit earlier. Let's have a look. It's a little bit too fast. Let's make it 9.2. So I think that's how you delete stuff from a vellum simulation. So it is like you need to delete them in the same time steps. And again, I actually only discovered this pretty recently, but again, you can see now it will be like this, and then the next frame it will be gone. So you can make a threshold there. Maybe I could actually let's do a command mark deleted by threshold. Oh no, not with getting confused in coding languages there. All right. So yeah, that's how you delete stuff from a vellum. And of course, these are not too many bubbles. But imagine if you have hundreds of bubbles, this is really going to make a difference. Because how I did it before, I knew this, like in my previous thing, I would just move them out of the way. So I just did like p.x plus equals whatever, and then added them to completely different coordinate. But yeah, of course, now they're actually completely removed from the simulation. So that's pretty cool. So yeah, that's the vellum sim itself, and I think pretty cool. Like quite a lot of interesting tricks. So now we can. Oh, there's one that's sticking over there. Maybe we should increase this thing to be a little bit more time in between bubbles. But yeah, now what we need to do is we need to just do the additional particle sim that's on top of this thing, where they pop. Again, a real bubble would probably pop a little bit faster, but I initially, I made this all a little bit slower because it's just for this tutorial. You can now really see them sort of the explosion grow around the thing, which I think is pretty cool. Oh, they're really good. Okay, I think these pop like should be right. You know what? Let's remove the expressions here. Let's just do 1, and let's just I don't want them to stick to each other. It's mainly. Oh, they're really too. Okay, let's move this thing to spawn a little bit lower. I think that might also help. Oh, no, that's not helping. Need to probably change maybe the randomization here. I'm gonna increase maybe the force that they're pushed up a bit. Right, that seems to help. Right, so you just need to tweak your tweak your stuff. So now that this is out of the way, let's do the particle explosion thing. So let's first go out of here. Let's go in this thing here. Let's grab and let's call this bubble object. Copy the name and object merge here. Let's only merge the bubble objects. Oh wait, we need to. I always get these wrong. In some you need to reference the full thing. And why is this not? I only want to. Why is it not? All right. Okay. All right. So there we have the entire thing. So we can cache this out. Let's do file cache. Again, like I have this preset thing, but like, so if this looks a little bit different, you don't have my preset thing, and then you can check out Tim run elsing and folder structure. Burp. All right, and then you can check this thing, and then you can download my preset, because these are presets that I use. Anyway, vellum bubbles. All right, let's save these out. Let's do like 200 frames or something. Oh, we need to. Oh, yeah, we need to do a switch or something to stop emitting after a couple frames. So let's do a switch. No, not sweep. Switch. Switcheroo. Switcheroo. Bam. All right. Null. Let's do null. All right. Let's just say $F above frame 100. So above frame 100 is going to switch to the null. Then no more instance points will be sourced and it will stop being instanced. And yeah, let's just save. Oh, we need to, by the way, cancel initialize simulation operators. All right, save out. Let's drink my coffee in the meantime. Good old coffee. Nice sun outside, and I'm sitting in here recording a tutorial. All right. Press play. All right. I kind of feel I'm not digging the randomization here. Let me just check what I did for the randomization on my original thing. All right. I just did $F times whatever, because it's not spawning anything on this one here. I'll just save another one out. You can see it's quite fast. Of course, it depends on your graphics card or your CPU, depending if you're running on vellum on CPU or on your GPU. By the way, you can change that in the preferences here. There is in miscellaneous, you can say like, do you want OpenCL device to be GPU or CPU? And then you can choose your graphics card there. But yeah, right. So it emits a couple of bubbles. Pretty cool. All right, so let's continue with just doing the sort of the particle explosion after this thing, and of course then we can render the whole thing. So we already saved out the color on here, but if you didn't do that, you could do another color here and then rem from attribute grow, and then we'd have the color here again. Then we do a we want to delete some points, so we could do delete expression at CD equals 1. So now you can see it would delete them by the thing, and probably, by the way, now I'm looking at this, we probably want a slightly higher resolution sim for the final sim. So let's increase the frequency a little bit on our things and save it out again. Sorry about that, because then we get a little bit of a sort of a nicer, smoother transition. Of course, it's gonna be a little bit slower, but still not too bad. So let me just wait for this to finish. All right, so now we have There we have a little bit of a more. Oh, probably. Now I'm looking at this again. Probably want to randomize this a little bit. Again, that's why we did the randomization that I removed, because now you can see they're constantly being removed from the same spot. All right, so let's just, I guess, let's go back in here. Let's do. All right, we want to sort them randomly. Can we do this? Let's do $F. Let's just see what this will come up with if we just save this out. All right. Boop. All right, so you can see the only problem here now is that it will sometimes transfer from multiple points. Actually, it doesn't really matter. It actually kind of looks kind of cool, if I'm honest. So now, because sometimes now it will blast another frame and then it will also fade away from the other side. But it looks pretty cool, to be honest. So we can probably keep that. Right. Now that that's truly out of the way, what we can do. So we have this stuff here. Maybe we want to smooth it maybe a little bit. Nah, let's just not do that. Subdivide it. Get a little bit more points in there. Let's group. And let's group edges. Turn off this. And let's include edges and do unshared edges. So in this case, we're gonna we're getting the unshared edges here. And then we're gonna color the unshared edges. So we're gonna get this stuff here, and we're gonna blur this slightly. So I'm gonna blur the color a little bit. You can see we can sort of set the edge that we kind of wanna, wanna emit from, and then from there we can delete the expression cd equals 1 and delete non-selected. All right, so now we get some sort of a strip here, and we could maybe say is if it's above if it's below, above 0.7. Let's have a look. Right, and then maybe we can increase the blur a little bit so we get a little bit of more of a fall off thing. So that's going to be our sort of our rim that we're going to emit from. We just template. So you can see we can put this into a simulation. Probably before that, what we want to do is do a facet here and generate some point normals. So here we have some point normals, and then we're gonna do attribute wrangle, or maybe we could do an attribute VOP. It's gonna be easier. We're gonna add some noise to it, and we want to say in this attribute VOP, we want to say put the normal into the velocity, and maybe want to do turbo load noise, and want to maybe randomize it a little bit. So let's do a multiply here and put the noise in. So again, like the normal is this vector pointing out, and we're gonna then we can use that as velocity on our particle sim that we're now going to do. And then with a little bit of noise here, we can sort of multiply that to make it a little bit more interesting. Right. Oh, we probably want... Let's have a look here. Why are we... Oh, we haven't promoted the frequency properly. Frequency, right. Simplex noise. Oh, let's do alligator, right? Something like that. Let's have a look at where do we have... Where did they go? Where did they go? All right. Oh, there they are. All right. And all right. All right, so you can see we have some velocity there. So let's do pop simulation. Pop network. All right, so probably want the ridge to be a little bit thicker. So we probably want to increase the blur a little bit. All right. All right, let's increase the birth rate. Let's change the life expectancy like 1.2, 1.2. So we can just get some randomization here. All right, that's pretty cool. All right, pretty simple. All right, and we need to have this cache here and load from disk to no geometry, else it's going to error once it doesn't find any geometry anymore. So in this thing, it's pretty. Maybe we want to actually increase the velocity a little bit that's coming in on this thing. So let's go to use inherited velocity, maybe multiply it a little bit by 2.5. Here's the simulation and play. Yeah, buddy. All right, that's pretty cool. Let's file cache this out. There we go. Call it pop sim. And let's do like 250 frames. Initialize, save the disk, should be pretty fast. Right. Yeah, now we have this entire thing. Now let's split this out to a couple of nodes. We can start using this for rendering. We can start configuring everything. So let's call this out particles. Let's grab a null here and do this. Or no, not a val cache. I want particles. All right. Let's do that one. All right. Out geo. Let's do, and we already have out tubes. All right, perfect. Let's do some render nodes. RNDR tubes. RNDR bubbles. And RNDR spray. All right. So let's hide these. Let's color code these green. Let's go into the tubes. Let's just do object merge and let's just put these in like that. Then go in here, bubbles, object merge, geo into objects, perfect, and spray. Object merge into object. There we go. Oh, where are our tubes? Tubes. Do I? All right, there we go. All right, so let's make a camera. Let's see what we made. All right, let's make camera. Let's turn off the rotation here. Let's make 90. Let's do like 80 millimeters. All right. Oh, should actually look through the camera maybe. All right. 1500 by 1500. Boop. All right, let's do flipbook. See what we made. 250. 1500 by 1500 and start. And go. All right. Oh yeah. Yeah, I recently I reinstalled my computer because my Windows got corrupted. So hooray. I thought that my disk got corrupted, but it didn't. But still. Alright, so yeah, so we have hey, there's some weird stuff here with the. Alright, let me check what's up with that. So something doesn't get deleted there. Oh yeah, because we all right, yeah. So in the spray here, in the bubbles, there we go. Just look through them. All right, so we wanna maybe do some alpha here in the viewport. So at alpha equals at CD. Oh, I want to invert that, and so I want to say fit 0 1 CD 1 0. So then they get inverted, right? So that looks a little bit more. Let's then just color code them with just something in the viewport, like something like that. All right, let's do another flipbook. Now this should be a little bit more correct. Why am I? 1 second. What am I? Bubbles, all right. Spray. Troops. Why am I still seeing? Okay, this is correct. All right, sorry for that. Thought I saw something weird, but I didn't. All right, so let's just play and have a look. All right. Let's just play and again, in terms of timing, I mean, just like do it, like you can change it up however you want, but the basic effect is the same. But yeah, you can change it up however you want. So with it out of the way, let's do some rendering. Of course, it's going to be quite. I mean, yeah, you have the thin film here. I'm gonna render it in Redshift again, like I always do. Feel free to follow along in any render engine, but or just skip this part if you want. But yeah, let's do the rendering part. Let's just draw some curves. Sometimes this curve thing does a little bit weird. All right, here we go. Boop. 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 Beautiful. All right. Something like that. All right. All right. Let's convert. Convert to NURBS curve. That's going to be nice and smooth. Then we're going to resample. Get some points. Then we're going to poly extrude. And we're going to do it in the point normal direction. You could set your own point normal if you're there, but it's already doing it in the correct direction. So it doesn't really matter in this case. Oh yeah, we accidentally moved our camera, so that's not what we wanted to do, but doesn't matter. We can just move our camera again. All right. So just a nice little backdrop-y thing. Let's make it a little bit bigger. All right, something like that. Oh, yeah, let's call this thing also. There we are. Backdrop, color code it. Let's do some redshift material. We'll first do a light dome, and I got a HDRI from HDRI Haven. Probably know I've mentioned HDRI Haven a ton of times, but they're amazing and they have a lot of free HDRIs. So start supporting them on Patreon if you want. They have A lot of free awesome HDRIs. So check it out. I have I made a where do we have it? Dollar job HDRI, and there we go. Put an HDRI in. Beautiful. Let's do our render view thing. All right, that's correct. All right, let's add some materials. View some bubbles here. All right, let's first do backdrop materials. I go to material, check material builder, backdrop, and let's just do something like a little bit dark, a little bit rough, like a little bit of refraction, a little bit of roughness, and let's just drag that onto our thing. Probably make it a little bit lighter. All right, let's do another light. Oh, we need to do the why is the light? All right, yeah. Need to make it darker again. All right, something like that. Let's do where is it? Let's do our shelf. Again, I had to reinstall my computer yesterday because like everything completely broke. That's why you never store important data on your Windows disk, which I don't, but just to keep in mind, because like I was back up and running within an hour or something. All right, let me move my camera a little bit. All right, here we go. All right, so let's do another. I made a redshift light, so that's right. All right, let's do it. Let's make it a distant light. Let's do intensity a little bit lower. Turn off the something like that. Temperature. That's right. Let's do some other materials first. That's your material builder. Metal. Let's make some metal. All right, aluminum. Troops. I'm gonna change these materials up in a little bit, by the way. But let's first do the basic material builder. Bubble. Let's do water, and let's do it on the bubbles. Let's do thin walled. All right, so in order to get sort of a nicer look for our bubbles, like I have here, we want a thin film shader. You need a redshift build above 3.4, the minimum. Thin. All right, so if you search for redshift, OSL, GitHub, you have OSL shaders here, and there should be a. So these are all OSL shaders in the Redshift repository. So Redshift supports OSL open shading, but I'm annoyed by my camera. I'm gonna move it. All right. Right. So Redshift supports OSL since version 3.4-ish. I'm still annoyed by my camera. Right. Yeah, it's OSL's open shading language. Is basically you can do shader programming. OSL is pretty cool. But there's a thin film shader here. Thin film interference. So this is the entire thing. I'll just put the thing in the download as well. So again, you can download the entire project file if you're a Patreon or on Gumroad. So let me just do stock for OSL and let me grab the thin film interference, and let me just go put it in the OSL folder. All right, so we can grab the thin film. So let's do we type OSL, we get the Redshift OSL. You can reference a file here. So I'm just gonna go to $job, I made a whole self thing here, and why is it? Oh, I copied the wrong thing, I think. Oh yeah, I copied some reference image. So that wasn't supposed to be the correct one. All right. The job, OSL, thin film interference, and then compile and build. All right, so you get that thing. So if I just put this in surface, it's gonna look like this. Press render again. All right, so something like that. Again, like you don't want to use it like that. You want to probably put it in your refraction color. Refraction, where are you? Refraction color. Boop. Put it in there. Just put let me just grab my old thing as a reference. Oh, I put it in reflection color, by the way. Sorry, reflection color. Bam. All right. All right. Let's increase the it's not looking the way I want it to yet. Let's go. Lighting is probably also going to make quite a big difference here, but it's already starting to somewhat look a little bit more like a bubble. Yep. Let's, by the way, increase our... Oh, no, not like that. So we have 2 open color. Yo. All right. Alrighty. Let me just check my... Oh, wait. I had my IRR on 1.5 and I didn't do much else. I think I just had something like that. Let me check how my OSL was configured. Right, 1.4, 1.44. Oh, not 144. 1.4. Again, just play with these values a little bit. This is just what I did for the original. So yeah, you have a couple of bubbles here. We can, I guess, increase the light dome a little bit. So let's maybe increase the reflection weight just above 1. All right, something like this probably looks pretty cool. In terms of the metal, what I had, let me just grab my original things. 1 second. So with the metal I had, if I go in here, I had some textures on it. So I have a little job here. Let's do texture. Fingerprint. We need to do triplanar because we don't have any UVs on these things. Triplanar mapping. Triplanar will just project UV sort of from every side. That's what, so you don't need UVs. It works great for like static objects like that. Oh, we don't want to do it in diffuse color, by the way. We want to do it probably in the reflection color. So reflection color. So this is a texture of fingerprints. Just metal looks just overall a little bit nicer if you have some sort of, if it's not completely clean, something like that. So now this is really black and white, so we probably want to fit range this. So range, so change range. And change the minimum range, then you get something like that. And another one. So this is the other one is from Megascans. So I cannot include this in the downloads if you get the downloads, but you can just search for this code and you will get the same one. But essentially, yeah, it's just pretty, like it's this thing. Let me just Just drag it in. I probably need to color correct it a little bit. Oh, I need to, by the way, do it with a triplanar if I want to show you like that, because there's no UVs. So it's like that, and then I could do color correct. Color correct. All right, here we go. And then increase contrast a little bit. Maybe increase the levels. No, or the camera. No, just play around with it a little bit. All right, something like that. I'm just gonna add that to this thing here, and then put the material on here. So just get a little bit of a more interesting sort of metal look. And again, let's play with this however you want, but I thought this was pretty decent. So basic material, we need to do the bubbles. So for the bubbles, we need to do some additional things in the like in the wrangle. So let's go in here. Oh, we also, by the way, still need to change some stuff in the. Let's first do that in the bubble. We want to load in our attribute, our alpha attribute. Let's call it alpha. And let's just plug it into our opacity color. Oh, scalar and then opacity color. Let's go to a frame where there's actually. Let's turn off our spray. All right. Right. So if I have here, I have one where there's actually some. Right. So if I put the attribute here in the alpha, it should be, you can see you get sort of the fade effect here. And we also want to do that on the spray. So we want to do a little bit of a ramp there. So we want to ramp the alpha here based on the age. So we're going to say float f equals fit 0, 1. No, not 0, 1. Sorry, fit. We're gonna age between 0, the life, and then we're gonna do 0 and 1. So we're gonna make a 0 to 1 value between 0 and our life. So life attribute on the points, of course, is the moment when they die, and the age. So we're fitting the age between that, and then we have a 0 to 1 attribute, and we're gonna say f at alpha equals channel ramp, alpha ramp, and f. So we're going to use the attribute f to do that. So move this down a little bit. Let's hide this and let's just check out one of these things. All right. There we go. And let's see what I had. Let me just try to sort of roughly match what I had before. So something like that, burp, and something like that. All right, so they would fade in and then fade out. Maybe they could fade out a little bit faster, but something like that. Probably need a little bit different material for this as well. By the way, let's first configure it to actually render. So let's go to Redshift OBA. Let's go to particles, render objects as particles, and let's get small. So let me just double check what my size was in the original thing, so we have at least a good guess. Oh, it was actually at 1. All right, let's just try that. And before we assign the material, let's just see what it looks like without material, and we can judge the size a little bit better probably. All right, so the size actually looks pretty good here. But purely we cannot really use this material here, because if we do this material, like the thin film shader here doesn't really work that well on things this small. You can see it get completely they completely disappear. So let's just copy and paste our bubble material, call this spray. Let's assign our spray material instead. Let's just remove the thing, the OSL thing here. So it's still, let me just do a bucket render maybe. So something like this, you can see it's a little bit easier to see. So let's just have a look at one of the... Maybe we want the size to be a little bit bigger. But something along those lines. So pretty basic. And then you configure your, you can configure your ROP here. I have a preset for it, but essentially you probably don't need secondary GI. So just use brute force. You could use it. It's not that right. Let's just leave it on. YOLO. Just eyeball some samples, like 128. Turn on motion blur, because we want motion blur, of course. Make sure to enable motion blur on your object. So let's go to settings. On your spray, mesh deformation blur from velocity attribute. Same on the bubbles. Redshift OBA, settings. Mesh deformation blur from velocity attribute. So we have some motion blur there. So if we now render, we should have some motion blur. And all right, there we go, motion blur. And yeah, I'm thinking that's essentially that's essentially everything. Yeah, probably want to change the, like, maybe I want to decrease the, like, in terms of light, like decrease that, whatever. I mean, you can play around with this yourself, like, to make an interesting look for your scene. I don't want to play around too much with the actual render here for the final sequence, but I mean, it's essentially what there was, what it was for the original render. So once you tweak your setting, your thing a little bit, you should be left with something like this. So yeah, that's the way the cookie crumbles. All right, so yeah, that concludes the entire tutorial. Quite a long one. I hope you enjoyed. Hope you learned a lot. I think it was like we discussed some pretty interesting things, like how to remove stuff from vellum simulations, use SOP solvers, you run on constraint geometry, regular geometry, a whole bunch of interesting things. If you did like it, make sure to leave this a thumbs up. If you want to download the source files, they're available for Patreon supporters. So if you want to support on Patreon, help out the channel, you can do that with the link in the description, patreon.com/TimvanHelsdingen. You can also just get the source files on Gumroad. They're also available over there. Also helps out the channel if you buy something on Gumroad. Thanks a lot. If you want to see more of my videos, make sure to subscribe, hit the bell icon. They get notified whenever I post new stuff. Like I mentioned, I'm working on a short film thing, which is coming out pretty soon. And then after that, there's going to be a whole bunch of educational content regarding that thing on the YouTube channel. So if you don't want to miss that, make sure to subscribe and hit the bell icon. Anyway, without further ado, thanks for watching, and hopefully I will see you in the next one. Peace.